day to all of you. This is the chapter 7 of my Thermodynamics 1. Chapter 7 is all about the internal combustion engine. Now, the internal combustion engine is a heat engine deriving its power from the energy liberated by the explosion of a mixture of some hydrocarbon in gaseous or vaporized form with atmospheric air. Therefore, as you can comprehend on this paragraph or this sentence, that the internal combustion engine is a heat engine deriving its power from the energy liberated by explosion. When you say explosion, it means combustion. When you say combustion, there is a fuel and air presence on it. Doon sa combustion engineering, on the higher subject of mechanical engineering, you will tackle the combustions of different kinds of fuel. May iba't ibang fuel tayo. And then, when you pair it with air, ano ang kanyang product? Should be water, carbon dioxide, and kung may excess air or kulang na air, siya naman ay may carbon monoxide. But this time in Thermodynamics 1, we're going to tackle the fundamentals of the internal combustion engine, which is the cycle, the Otto cycle and the diesel cycle. The first cycle is the gasoline engine or the gasoline cycle. The gasoline engine is also called the spark ignition engine. Kapag sinabing gasoline engine, siya ay Otto cycle. And for the process of the 4-stroke cycle gasoline engine, the first stroke or the half revolution is the intake. When the crankshaft revolve, half revolution ng crankshaft, the connecting rod that are connected on the piston will goes down until it reaches its bottom dead center. Then after it reaches down its bottom dead center, the air fuel mixture will pass through the air intake valve and it will be accumulated on the cylinder. And for the other half revolution, which is the first revolution of the crankshaft, the piston pushes upward until it reaches its top dead center, therefore compressing the air fuel mixture in the cylinder. And for the another half revolution, which is 1.5 revolution, which is the power, when the air fuel mixture is compressed in the inside of the cylinder, the spark plug, matitrigger niya yung spark plug doon. And kapag na-trigger niyo yung spark plug doon, therefore it will create a friction, therefore it will create a spark, and therefore it will create a fire, apoy. So, kapag naglagay siya kapag nag-spark siya containing an air fuel mixture, therefore magko-combust yung nasa loob ng cylinder. And then the other half revolution or the second revolution, which is the exhaust, lahat naman na nasusunog ay nagkakaroon ng usok. So therefore, the exhaust gases after the combustion will pass through the exhaust valve. So therefore, your half revolution, 1 revolution, 1.5 revolution, and pangalawang revolution. So therefore, there are 2 revolutions to take place in a 4-stroke cycle gasoline engine. A cycle begins with the intake stroke as the piston moves down the cylinder and draws in a fuel-air mixture. Next, the piston compresses the mixture while moving up the cylinder. At the top of the compression stroke, the spark plug ignites the mixture. Burning gases push the piston down for the power stroke. The piston then moves up the cylinder again, pushing the burn gases out during the exhaust stroke. Now, the 4-stroke cycle is one wherein 4 strokes of the piston, 2 revolutions are required to complete a cycle. Now, for the Otto cycle, sabi ko nga that the gasoline engine is a Otto cycle. The Otto cycle is the ideal prototype of a spark ignition engine. The spark ignition engine is also called a gasoline engine. Now, for the process of the Otto cycle, ang mas maganda nating dapat malaman is the TS diagram. Why? Kasi there is the isentropic process in it. So therefore, it's easy for you to draw the diagram of a Otto cycle if it is on TS diagram. So therefore, dito tayo magpo-focus sa TS diagram. Siyempre, pinakita ko din naman sa inyo how to draw it in a PV diagram, but this is more easy for you to draw. Now, for the TS diagram for Otto cycle, the first cycle is process 1 to 2. Process 1 to 2 is the isentropic compression. Next is the process 2 to 3, which is the constant volume heat addition. So therefore, constant volume siya. And then for the 3 to 4, the isentropic expansion. And for 4 to 1, constant volume heat rejection or the isometric process. Now, for the air standard cycle means that the air alone is the working medium. So for the analysis of the Otto cycle, kung mako-comprehend nyo o maiintindihan ninyo ang pagdodrawing ng TS diagram ng Otto cycle, it's easy for you to derive from this equation, from this diagram, all the formulas you need to solve a problem. So for the analysis of the Otto cycle, you have your QA. QA is the process of 2 to 3. Therefore, anong process 2 to 3 natin? 2 to 3 natin is isometric compression heat addition. So therefore, what is the formula on Q in constant volume? mCv delta T. Please be careful on the usage of the specific heat. Ito ay CVY kasi constant volume. So therefore, it is mCv delta T. And for the QR, which is the heat rejection, some process siya. Process 4 to 1. Which means it is constant volume or the isometric. So therefore, mCv delta T pa din yung gagamitin mong formula. Now for the work, just like what I said on the Carnot cycle, the energy in equals energy out. So therefore, your input equals your output plus your heat rejection. So therefore, your output here, which is your work net, is equal to your Q added minus your Q rejected. Then for your efficiency, which is work net over Q added or your output over your input to solve your efficiency. And this is the derived formula here. Dinerive lang natin siya. Therefore, you have another equation for your efficiency in Otto cycle is 1 minus T4 minus T1 all over T3 minus T2. This is in terms of temperature. So, kung sa problem, ibinigay na temperature yung lahat, madali mo nang ma-solve yung efficiency. And now, another equation for the efficiency is using the isentropic compression RK, which is 1 minus 1 over RK raised to K minus 1. The formula for RK is V1 over V2. How to solve? Paano natin ito na-derive? Let's discuss the derivation of the formula for efficiency. On process 1 to 2, kung matatandaan nyo, process 1 to 2 is the isentropic compression. So, anong PVT relationship natin sa isentropic? Si Theta Vk, si Tpk. Dito si Theta Vk yung gagamitin natin. So, Theta over T1 equals V1 over V2 raised to K minus 1. V1 over V2 is equivalent to RK. Therefore, your T2 equals T1 times RK raised to K minus 1. Si Theta Vk. Okay? So, don't forget. Tapos, isa naman is Tpk. You have your pressure and your K minus 1 over K. Now, for the process 3 to 4, process 3 to 4 is the isentropic expansion, si Theta Vk ulit, So, therefore, your T3 equals T4 times RK raised to K minus 1. Now, substituting the equation 2 and 3 in the equation 1, which is here, which is this, the formula now would become 1 minus T4 minus T1 all over T4 times RK raised to K minus 1 minus T1 times RK raised to K minus 1. Now, using the property of equality, your T4 minus T1, quantity T4 minus T1 is times RK raised to K minus 1. So, therefore, you have to cancel out the T4 minus T1. Ang matitira mo lang is 1 over RK raised to K minus 1. So, that is the derived formula of the efficiency. So therefore, you have three formula of efficiency, which is in terms of temperature, which is in terms of isentropic compression, and which is in terms of output over input. Now, for the work from the PV plane, your work is the summation of all the works in the process. Work ng 1 to 2, work 2 to 3, work 3 to 4, work 4 to 1. Okay? So, for the clearance volume or the percent clearance. Now, we will go to introduce the clearance volume, the percent clearance. Why? Because there are some problems that has a percent clearance, which is easy for you to solve for the isentropic compression, because isentropic compression is equal to 1 plus C all over C. So, ito lang yung tatandaan mo pag meron kang percent clearance. And ang tip ko sa inyo, you have to solve first, or you have to find first the value of RK for you to easily solve the remaining parameters. Ano? Kasi mas madali kapag meron ka ng value ng RK. Now, for the ideal standard of comparison, the cold air, which is the standard K, equals 1.4, and the hot air, which is standard K, which is less than 1.4. Now, this less than 1.4, this standard is 1.3. So, the technique of that, ano, kung 1.4 siya, there are 4 letters in cold. So, therefore, 1.4 siya. Whereas sa hot, 3 letters lang, so 1.3 siya. Ano, para hindi kayo magkabaliktad kung ano yung inyong K for cold and hot air. Now, for the thermal efficiency of the theoretical Otto cycle, increased by increased in RK. Therefore, the higher the RK, the higher the efficiency. For the increase by increase in K, the higher the K factor, the air factor, the higher the thermal efficiency. And it is independent of the heat added. Now, the average family car has a compression ratio of 9:1. Now, sa problem, ganito pag minsan ang binibigay. Proportion, 9:1. So, therefore, ano ang compression ratio mo dyan? Your RK is equivalent to 9 because 9 over 1 yan. But, another example, if your compression ratio is 10 over 5, therefore, 10 divided by 5, ang compression ratio mo ay 2. Ano, ganun lang. Now, the economic life of the average car is 8 years or 8,000 miles of motoring. So, therefore, if you are going to buy a car, a second-hand car, that is from model 2012, ano, pwede mag-isip-isip na kayo kung gusto nyo pa ding bilhin. Why? Kasi, sabi dito sa claims natin that the economical life of the average car is 8 years. So, therefore, kung 8 years na siya at gusto mo pa ding bilhin, you may, ano, from time to time, baka masiraan kayo and you have to overhaul it. And the worst, parang sa pagpapagawa nyo, parang mas bumili natin kayo ng bago. Ano? So, you have to be very careful then, ano, the span of the engine. It should be not more than 8 years. Ano? Or the 8,000 miles or motor, whichever comes first. The 8 years or the 80,000 miles of motoring. Now, let's solve problem exercise number 1. An Otto cycle operates on 0.5 pound per seconds of air from 13 psi and 130 degree Fahrenheit at the beginning of compression. The temperature at the end of combustion is 5,000 degree Fahrenheit. Compression ratio is 5.5. At air standard for K is 1.3. Now, find the V1, the P2, the T2, the P3, the V3, and the T4. Compute the Q added, the Q rejected, the work net, and the efficiency, and its corresponding HP. Now, let us go to letter A muna. Letter I. The V1. V1 is here in point 1. So, you have your values for, you have your mass, you have your P1, you have your T1. So, therefore, using the equation PV equals MRT, you can solve for V1. Your pressure is 13 psia. Your volume is your hinahanap, and your mass is 0.1 pound per second. Your R, which is constant, 53.34, and your temperature, which is 130 plus 460. Therefore, you have V1, which is equivalent to 1.68, 1121795 cubic feet per second. And now, for the P2, you see, P2 is in the process of the isentropy. Dinaanan niya is isentropic process. Hindi ka pwedeng mag-rely dito ng process which is isometric. No. ang pagsosolve po ng bawat state point ay kung ano yung madadaanan niyang process. So, in process 2, you have nadaanan mo process is isentropic. So, therefore, you have your computation which is P2 over P1 equals V1 over V2 raised to K. Ano po itong formulang ito? Ito ay pinagsama lang natin si Tita Vicky at saka si Tita K. Pag pinagsama mo iyon, tinanggal mo yung temperature, ito yung magiging kalalabasan na equation. So, you have your P1 which is 13 PSIA, you have your V1, and may V2 ba tayo? Wala tayong V2. But, meron tayong compression ratio. Kasi ang compression ratio is equivalent to V1 over V2. So, therefore, your P2 is equals to P1 which is 13 times 5.5 raised to 1.3. And your answer on P2 is 119.2380,455 PSIA. And now, for the T2, temperature at state point 2, ang nadaanan din natin yan is isentropic. So, pwedeng gamitin natin is si Tita Vicky na T2 over T1 equals V1 over V2 raised to K minus 1. Again, wala tayong V2. So, meron naman tayong compression ratio. So, okay. So, yun yung gagamitin natin. Therefore, your T2 is equivalent to your T1, which is 130 plus 460 times 5.5 raised to 1.3, which is equivalent to raised to 1.3 minus 1, which is equivalent to 983.922335 Fahrenheit. And for your P3 naman, nadaanan na natin ito. Ang process natin dito ay isometric heat addition. So therefore, what is the formula on getting the pressure in a PVT relation in constant volume? So tanda pa yung P1 V1 over T1 equals P2 V2 over T2. So yun doon natin siya kukuhanin. Therefore, in getting your P3, you have your P3 over T3 equals P2 over T2. Your T3 which is 5,000 degree Rankine, and your P2 which is yung sinolve natin na 119, and your T2 which is yung ating sinolve kanina na 983. Therefore, you have your P3 which is equivalent to 605.93223034 PSIA. And now for the V3, volume 3 naman tayo. Volume 3 tayo, nadaanan natin is isometric heat addition. So therefore, bago natin makuha yung V3, kailangan muna natin masolve yung mga V dito. Meron na tayong V1, wala tayong V2. Wala din tapos ito naman yung V3 hinahanap natin. Now, take note that the process 2 to 3 is isometric. So therefore, it is constant volume. So therefore, V3 equals V2. And para mahanap naman natin yung V2, meron naman tayong compression ratio, di ba? Which is 5.5. Compression ratio is equals to V1 over V2. So therefore, 5.5 equals V1, which is yung sinolve natin kanina, all over V2. So therefore, we have your V2 equals V3 equals 0.305658082 cubic feet per second. And now, for the last problem, for the last required on the letter A is the T4. The T4 naman, ang process 4 natin at point 4 natin, dinaanan natin is isentropic. So therefore, si Tita Vicky ulit yung pwede natin gamitin. Si Tita Vicky. T4 over T1 equals V3 over V4 raised to K minus 1. Please take note, the V3 and V4 is the compression ratio as well. Kasi, why? Kasi, your V1 over V2 equals V4 over V3. Kasi siya ay same process lang. Paulit cycle lang siya. Inulit lang. SV. Isentropic, isometric, isentropic, isometric. So therefore, yung compression ratio mo dito, pwede din siya compression ratio mo dito. So therefore, your T4 is equivalent to your T3, which is 5,000 times 5.5 raised to 1.3 minus 1, which is equivalent to 2998.204126 Rankine. Now, for your Q added is in the process 2 to 3. Constant volume, therefore MCV delta T ang gagamitin mo. we have mass, we have the T3 and we have the T2, but we don't have the CV. Hindi mo siya pwedeng gamitin CV yung standard natin. Kasi ang binigay naman sa ating K is 1.3. So therefore, you have to find first what is the value of CV. Kung matatandaan nyo yung sinabi ko dati on how to get a CV and CP of the problem. Kung ikaw ay CP, ikaw ay RK. Kung ikaw ay may CP, ikaw ay RK. Therefore, the formula for CP ay RK, which is RK over K minus 1. Wherein sa CV, ikaw ay R over K minus 1 lang. Para kayo ay hindi malito sa pagsasaula ng formula. So, your CV equals R over K minus 1, which is equivalent to 53.34 divided by 1.3 minus 1 times yung ating conversion factor na 778 to make it in BTU. So, therefore, your CV equals 0.2285347044 CV, yung CV natin. And for the QA, which is MCV delta T, you have your 0.1 pounds per seconds, then you have 0.022, and you have your T3 minus T2, which is equivalent to 91.7813112222 BTU per second. And for the QR, same process then, MCV delta T. So you have your negative 55.03115682 BTU per second. Now, please do not be confused on the negative sign here. This negative sign here denotes that this heat is rejected. But it doesn't mean na siya ay makikarry over mu on the equation of work. Kasi ang equation ng work natin is QA minus QR. So therefore, you have your 91.78 minus 55.03. Hindi mo to i-carry over itong negative kasi pag nagkataon, magiging 91.78 siya minus negative 55. So, mag-iiba na ng sagot. Hindi mo siya i-carry over. It just distinguishes between the heat added and the heat rejected, yung negative sign. So, therefore, you have your work, which is 36.75. And for your efficiency, which is your output over your input, you have your 36.75 divided by your QA, which is 91.78, which is equivalent to 40.04099954%. And for your corresponding HP, all you have to do is to convert your work net into an HP. Before the conversion factor of the HP, the conversion factor of BTU per minute into HP is 42.4. And for the BTU per hour is 2545. So, ibig sabihin, for your 42.4 BTU per minute equals 1 HP, all you have to do is to convert first this work net into BTU per minute, since siya ay BTU per second. And then you divide it by 42.4 to be able to get 52.00493547 HP. And that's it for the problem solving on the Otto cycle. Ganon lang naglalaro yung problems sa Otto cycle. Madali lang naman siya. Same process lang din. And then, let's start for the compression ignition or the diesel engine. Now, the Otto cycle is spark ignition. Wherein ito, compression ignition. Wala na siyang spark plug para mag-trigger. Using compression, kasi mag-accumulate ng high temperature, therefore, masusunog yung air fuel mixture mo. So, therefore, magkakaroon ng combustion. Same process din. They have revolutions the intake, the second revolution is the compression, the another half revolution is power, and the another half revolution is the exhaust. So, therefore, there are 2 revolutions in a 4-stroke cycle diesel engine. Our cycle begins with the intake stroke when the piston moves down and draws air into the cylinder. The piston rises and compresses the air. During the compression stroke, the temperature of the air rises to about 900 degrees Fahrenheit. When oil is injected into the cylinder, it mixes with the hot air and burns explosively. Gases produced by this combustion action push the piston down for the power stroke. During the exhaust stroke, the piston moves up again and forces the burn gases out of the cylinder. Now, one more thing. Sa combustion engineering nyo din, sa higher engineering nyo, doon nyo din malalaman bakit nga ba hindi pwedeng lagyan ng ibang gasoline, ng ibang gas, ng ibang fuel ang diesel na makina. Specifically sa mga sasakyan natin, kung diesel lang yung ating pwedeng ilagay, hindi pwede ang kerosene kasi masisira, kakatok. Hindi naman sa kakatok, hindi siya tatakbo. Why? Kasi there are different molecular formula of the fuel. And yung diesel engine natin is designed for a diesel engine only. Hindi mo siya pwedeng samahan ng ibang fuel. So yun. Now for the PV and the TS diagram of the diesel cycle, if I were you, I'm going to use the PV diagram here instead of the TS diagram. Why? Kasi meron tayong constant pressure and constant volume sa ating process. So, mas madali kung PV diagram yung gagamitin mo. Siya ay SPSV. The isentropic, the isobaric, the isentropic, and the isometric. SPSV. Para hindi kayo malito, kung sa diesel at sa auto, sa auto kasi is SVSV. Sa diesel is SPSV. Pag sa auto, sub-sub sa auto. SVSV. Sub-sub sa auto. Wherein dito sa diesel, SPSV. Sa Petron, Savi, magpa-diesel. SPSV. Sa Petron, Savi, magpa-diesel. S, isentropic. P, isobaric. S, isentropic. V, volumetric. Isometric. So, SPSV. Sa Petron, Savi, magpa-diesel cycle. Diesel. Sa Petron, Savi, magpa-diesel. Sub-sub sa auto, SVSV. Isentropic, isometric, isentropic, isometric. Now, for the analysis of the diesel cycle, QA. Ang QA natin is in the process 2 to 3, which is the isometric heat addition. Isobaric heat addition tayo. So, therefore, you have, ba formula natin ng Q? Your Q is MCP delta T. So, ibig sabihin, please take note of the specific heat na gagamitin natin na constant. Since it is constant pressure, CP yung gagamitin mo. So, MCP, delta T, and for your QR, which is the isometric constant volume, MCV naman yung gagamitin mo. And for your work, ganun din, QA minus QR, and for the efficiency, ganun din, which is W over QA. Therefore, upon deriving that, we have 1 minus T4 minus T1 all over K times the quantity T3 minus T2. And po itong mahabang equation na ito? Ito ay derived formula in terms of compression ratio and cut-off ratio. Now, the compression ratio here is V1 over V2. And the cut-off ratio is V3 over V2. Now, the derivation of the formula for efficiency, ito, how do we derive that formula? In process 1 to 2, which is the isentropic, you have theta V2. Which is T2 equals T1 times RK raised to K minus 1. In process 2 to 3, which is the isobaric. So, PVT relation tayo. T3 over T2 equals V3 over V2, which is equivalent to RC. Tapos, ang T2 naman natin ay ito. So, therefore, T3 equals T1 times RK raised to K minus 1 over times RC. And for process 3 to 4, isentropic, si theta Vk ulit. Ito. So, therefore, sinubstitute lang natin, you have your RC times R raised to K minus 1 over RK raised to K minus 1. Which is, your T4 equals T1 times RK raised to K minus 1 times RC multiplied by the quantity of RC raised to K minus 1 all over RK raised to K minus 1. And simplifying it up, we have your T4 equals T1 times RC over K. Now, substitute equation 5, 6, 7 in equation 4, which is your efficiency. Makakam up na natin ito kapag sinimplify natin, which is 1 minus 1 over RK raised to K minus 1 times RC raised to K minus 1 all over K times quantity RC minus 1. Now, sir, parang ito po ay familiar. This is the efficiency of Otto cycle. Can we able to solve? Is it okay to solve first the efficiency of the Otto cycle, then we multiply it by the factor of the cutoff ratio? No, it can't be. Kasi on the rule of our mathematics, the PEMDAS rule, you have to multiply it first. before you subtract it into 1. Kasi kung unahin mo i-subtract ito, then you have to multiply, magkakamali ka ng answer. Magkaiba yan ng sagot. The efficiency of the diesel cycle differs from that of the Otto cycle by the bracketed factor RC raised to K over 1 over K times RC minus 1. This factor is always greater than 1 because RC is always greater than 1. Thus, for a particular compression ratio, the Otto cycle is more efficient. However, since the diesel engine compresses air only, the compression ratio is higher than in Otto engine. An actual diesel engine with a compression of ratio 15 is more efficient than an actual Otto engine with a compression ratio of 9. For you to satisfy your curiosity, if this claims is correct, try to solve the efficiency using the compression ratio. Ang compression ratio mo is 15 sa diesel, efficiency, and sa Otto naman is 9. Tapos tinan mo kung alin yung mas mataas na efficiency. And then, sabi din dito, RC is always greater than 1. So, therefore, sa problem pala, kapag sinabi sa problem, kahit na the cutoff ratio is ganito, but hindi naman sinabi sa problem na it is a diesel cycle, automatic na siya ay diesel cycle. Pero may condition. Kung ang RC mo is greater than 1, at hindi sinabi na siya ay diesel cycle, automatic na siya ay diesel cycle ang gagamitin mo. But kapag siya ay RC equals to 1, kasi hindi naman sinabi kung anong type ng diesel, it may be an auto cycle. Kasi kailangan ng RC mo, your cutoff ratio is greater than 1. Okay? Now, for the relationship among the compression ratio, the cutoff ratio, and the RE, which is the expansion ratio. The expansion ratio is V1 over V3. Huwag kayong malilito. V1 over V3 is the expansion ratio, wherein V1 over V2 is the compression ratio. So, ayun yun. So, therefore, the relationship of the three, RK equals RC times RE. Now, for the problem exercise number 1, a diesel cycle operates with a compression ratio of 13.5 with a cutoff occurring at 6% of the stroke. State 1 is defined by 14 psi and 140 degree Fahrenheit. For the hot air standard with K equals 1.34 and for an initial 1 cubic feet, compute T2, P2, V2, T3, V3, P4, and P4. The QR, the work net, the efficiency, and the PM, the mean effective pressure, and a rate of circulation of 1000 CPM and compute the horsepower. Now, for the T2, for the T2, yung ating alam na formula na T1 times RK raised to K may theta BT. Tas ito lang yun. So, therefore, you have your 1453 times 666,331. Yun yung ating sagot. Now, don't mind of these letters. Ito kasi ay, kapag nag-solve ka, you better store it on your calculator for later use. Para hindi ka na mahirapan magta-type parang mahaba sa calculator mo. And it takes time sa pagta-type. So, all you have to do is to know how to store on the calculator. Kung hindi kayo marunong mag-store sa calculator, I have a separate video there. The basic techniques, the basic calculation techniques, you may free to watch it on my video. Okay? Now, for the P2, which is P1 times RK raised to K, doon din, we have 457.90 PSIA. And for the RK, which is equivalent to V1 over V2, hanapin natin yung V2 natin. Your RK is equivalent to compression ratio 13.5 equals V1, which is yung nasolve natin kanina, all over V2, which is equivalent to 0.07. And for your V3, using your percent clearance, kasi meron tayong ibinigay na occurring at 6%. You have your RC cut off occurring at 6% of the stroke. So you have the formula of V2 plus RC VD. So therefore, you have your V3. Okay. So you have your V2 plus 0.6 V1 minus V2, which is your volume displacement. And you have your V3, which is equivalent to 0.129629696 cubic feet. And for your temperature 3, your T3 is 2543.916079 Rankine. And for your T4, your si Tita Vicky, your V3 over V4, na-solve mo na, or pwedeng yung nasa problem, yung gamitin, which is equivalent to 1,270.054143 Rankine. And for your P4, which is P3 times V3 over V4 is okay, which is equivalent to 29.63459667 PSIA. And for the heat rejected is MCV delta T. So, sa MCV delta T, we have your mass. May binigay tayong mass. May binigay ba? Walang binigay na mass. So, therefore, it is equivalent to 1. And then, you have your CV. Ang mass natin is, kinompute natin using PV equals MRT. Ito. And you have your CV, which is ito, K over, R over K minus 1. And then, you have your CV, sinolve din natin, RK over K minus 1. So, we have your MCV delta T. So, makukuha natin yung QR. And for the work net, kailangan natin ng QA. So, solve muna natin yung QA, which is MCP delta T naman. And for you to solve the work net, QA minus QR, which is equivalent to 10.45. And for your efficiency, your work net all over your QA, which is 54%. And for your mean effective pressure, you have your work all over 1 minus V2, which is 58.61817117 PSI. And for your letter D na ba siya? And for your letter E, for the rate of circulation of at 1,000 cubic feet per minute and compute the horsepower. All you have to do is to multiply the work net by your 1,000 CFM, and you have to convert it into HP, which is, yung conversion natin is 42.4 BTU per minute. So therefore, you have your 237.0283,019 HP. And that's it for the problem on diesel cycle. Ganun lang din naglalaro ang problem ng diesel. So if you have any questions with this topic, you may free to comment below your question. And if you want a copy of this PDF, you may comment down below also your email, and I'll be commenting down on the description box my email for you to email me if you want the copy of this PDF. I hope you learned from this lesson, and stay safe and God bless. Thank you.